Hello students, this is the third video on root locus, and here we will use the standard procedure for construction of root locus. Let's begin with the examples. Earlier we have discussed three examples with some analytical mean for finding that by finding the different values of k for construction of root locus. Here we will prepare a solution with the standard procedure. See here, the system is a unity feedback system, open loop transfer function, two open loop poles and no zeros. So draw the root locus using standard procedure, and with the extension determine the value of k for some damping factor, which is 0.707. So let's begin with the procedure. First step, the root locus always begins from the open loop poles. Here the open loop poles are at s is equals to 0 and s is equals to -4. So these are starting locations of root locus. Of course they will begin with k is equals to 0. Step 2, as there are no open loop zeros, therefore we have two locus. So root loci terminates at infinity because there are no open loop zeros at system parameter k is equals to infinity. Step number 3, the number of branches. The number of poles are 2, number of zeros are 0, and therefore the number of root locus branches n is equals to number of poles, that is 2. Step number 4, the root locus on real axis adjust between s is equals to 0 and s is equals to -4. The locus begins from 0 and -4. The locus approaches towards each other, and at one point they breaks. So step number 5 is the breakaway point, and for breakaway point we have to find out the expression dk by ds. See, the k expression for us with characteristic equation is minus s square minus 4s. So the first derivative of this equation is equals to, by taking the first derivative with respect to s, we will have minus 2s minus 4, and further equate dk by ds is equals to 0. So by equating this expression minus 2 minus 4 is equals to 0, we will have s is equals to -2. So the root locus breaks away from the point -2. We will proceed further. Step 6, the angle of asymptotes are given by the equation 2k plus 1 into 180 degree upon p minus z, where k is equals to 0 up to p minus z minus 1. Here p is 2, z is 0, and therefore the k options we have either 0 or 1. The two asymptotes the angles we will have, the first angle by substituting k is equals to 0. After solving this, we will have 90 degree, and when for the another option k is equals to 1, the another angle we will get by substituting k is equals to 1 here, and that is 270 degree. Step number 7, the asymptotes intersects at real axis at a point, that is x is a point of intersection, which is given by summation of pole values minus summation of zero values upon number of poles minus number of zeros. In our case, the values of poles are 0. It is a summation, so 0 minus 4 minus no zeros upon number of poles are 2 and number of zeros are nil. Therefore, after solving this, the point of the asymptote intersection point on real axis x is equals to -2. These 7 steps are sufficient because this is a simple case. So when we substitute or when we construct a root locus using this data obtained from 7 steps. First, step number 1, put the number of poles. Root locus begins with 2 open loop poles. We have 2, so cross at 0 and cross at -4. These are the starting point of root locus. The first branch originates from this, s is equals to 0, and second branch originates from s is equals to -4. Of course, the independent variable system parameter k is equals to 0 for respective locations. Step number 2, they terminates at open loop zeros. If number of zeros, open loop zeros are not there, then the locus terminates at k is equals to infinity. And see here, there is no termination with open loop zeros as zeros are absent. Number of branches are 2, another, okay. Then the breakaway point is equals to s is equals to -2. It means that the locus, it progresses, the first branch it progresses up like this till s is equals to -2. Another branch it comes from this side, and at s is equals to 2 the root locus breaks. Now we need help of the asymptotes. So let us construct the asymptotes. We have 2 angles. In step number 6 we got 2 angles. One is 90 degree and one is 270 degree. So as this is the very simple case, so the asymptotes are hidden here. The branch is, it progresses in this fashion, making angle of 90, and another branch is making angle at 270. Thus the first branch in this way and second branch in this way. So very simple case. Let us summarize the root locus in S-plane. We have 2 branches, the beginning points, the first branch, second branch with the angle of asymptotes. Another case is given here. We have to find out the value of k at one damping factor. So the damping factor is given as 0.707. So therefore there is an expression or the relation, the angle theta is equals to cos inverse of zeta, and by substituting damping factor of 0.707, we will have the point of we will have the angle theta is equals to 45. So put this mark with angle of 45 with the horizontal axis in this way from clockwise sense. Look at the angle of asymptotes, they are plotted in anti-clockwise sense, and this theta is to be estimated by clockwise sense. So this is the mark for that. Now we'll have the point of intersection with this, and therefore the root locus at s is equals to -2 minus j omega is to be computed, and with this or this is the point at which this line is going to intersect, and therefore by substituting that value we will get this. We have to take help of this magnitude mod of g of s. This is the standard requirement. Mod of g of s, h of s is equals to 1, and by substituting this and by substituting the point of intersection with that zeta, we will have this. So let us solve it further, and finally let's come out with the k value. Finally the k is equals to h. So this is the another requirement which was given as a part B of the statement. After all, the purpose of example 1 is to understand how to use the procedure for construction. This is the another example. Slightly we have the modification. Sketch root locus with 3 open loop poles. Again, for simplicity we will not assume zeros. By procedure step number 1, the root locus branches that begins respectively from this beginning location open loop poles s is equals to 0, s is equals to -1, and s is equals to -3. There are no zeros, therefore the terminations at infinity. Number of branches, step number 3, n is equals to p. You can understand there are 3 branches, okay, because no zeros, so number of poles 3, therefore number of branches are 3. Step number 4, the root locus on real axis exists between first pair, that is 0 and -1, and this another one, it will proceed further on the real axis. Between open loop poles there is a breakaway point, and therefore get the first derivative, first the characteristic equation, rearrange for k, take first derivative, and we have the first derivative as -3s square plus 8s plus 3. I hope you understand. We have limited time, so we'll little run fast. So substituting k is equals to s is equals to 0, we will have breakaway point. Okay, as the breakaway point has to lie between the first pair, that is 0 and -1, therefore the first root is applicable, and therefore the breakaway point bp is s is equals to -0.45. Step number 6, the angle of asymptotes are given by this, and the k varies up to p minus z minus 1. So we have 3 poles, therefore 3 options for k, 0, 1, 2. Sorry. So respective angles are computed here by substituting k is equals to 0, k is equals to 1, and k is equals to 3. So we have respective angles as 60 degree, 180 degree, and 300 degree. Step number 7, the point of the asymptote. The x is summation of values of poles minus summation of zeros upon p minus z. So we will have the summation of pole values, no zeros, therefore this summation upon 3 is equals to minus 1.33, and this is the point where all 3 asymptotes they intersect to each other. So again, this is a simple case. So by putting this data, see the first branch it originates from s is equals to 0, another branch it originates from s is equals to -1, and this is the third one. So first branch it runs in this way. We need of course help of put the asymptotes. They will help you because the branches run parallel with the asymptotes. So this dotted line indicates the first 2 asymptotes making angle 60 and 300,